Okay, these examples say to use the leading coefficient test to determine the end behavior of the polynomial function. Okay, so again we want to make sure we look at the term that has the highest exponent. So 2x squared, since it's even, that means that the graph will have the same behavior at the ends. So then we look at the actual coefficient, the positive 2. So because that's greater than 0, that means that the graph should be rising to the left and to the right. So we'll just say rising to the left and to the right. So both sides would be going up. You don't have to actually graph here, but just tell what the end behavior would be. Okay, if I look at number 7, my leading coefficient should actually be the negative 2x cubed. That's the highest exponent. So because my exponent is odd, that means I'm going to have different behaviors. One side will be rising, one side will be falling. So then I'll look at the actual coefficient, which is negative 2. Because it's negative, that means that my graph should be falling to the right. Okay, so we're going to say falls to the right and rises to the left. Number 8, f of x equals negative 4x to the 4th plus 3x cubed plus 4x squared plus 3x plus 5. My leading coefficient is the negative 4x to the 4th. Okay, because my exponent is even, this means I'll have the same behavior at each end. Because the leading coefficient is a negative 4, that means that the behavior will be both falling. So we would say falls to the right and falls to the left. Okay, if I look at number 9, this is a polynomial function, but it's just not written out in what we would say the general form. It's written out in kind of in factored form. Think if I multiply this out, okay, what is x plus 5 cubed? Well, I know that this term would end up being an x cubed, and then if I multiplied it by x plus 3, that would give me an x to the 4th, and then again here would give me an x to the 5th. Okay, so if it helps, you could actually multiply these all out exactly, or just look at those first variable terms and know this would be x cubed times x would be x to the 5th. So that's what my leading coefficient would be. Because it's odd, I would have different behaviors at the graph. Because the coefficient is a positive 1, with it being positive, that means that my graph would rise to the right, fall to the left. So the left part of my graph would be going down, the right side would be going up. Okay, number 10, the example, says to find the zeros, all the values of x for which f of x is equal to 0 of the polynomial function. So we want to find our x-intercepts. So we can do that just by setting the function equal to 0. Okay, remember to solve this we may have to factor out an x. So that would give me x squared plus x minus 42 equals 0. Okay, this polynomial will also factor if I look at what will multiply to be negative 42 but subtract to be 1. So that would be x plus 7 and x minus 6. Okay, so if I set each one equal to 0, one solution would be x is equal to 0, one would be x is equal to negative 7, and one would be x is equal to 6. So those are my 3 x-intercepts, okay, which also we call the zeros of the function. These would be the values where that function would cross the x-axis.